Unit 7 MCQ. I got a 5 out of 10 on this. The first problem I got wrong was the pendulum one. We had two pendulums. And it said that they both had identical strings and the same angular displacement. So they're pretty much the same except for the mass. The mass is the only thing that's different. And it's asking for the kinetic energy. So this is just kinetic energy. K equals 1/2 mv squared. So what is it? Just asking for the maximum kinetic energy. So this one would be the bigger one. So K max 2 is greater than K max 1, simply because the second pendulum has a greater mass. So that was first question I got wrong. The next one I got wrong was, oh, okay, well. This object is in simple harmonic motion. Which set of three can have the same maximum magnitude at the same time? So let's just put that into perspective. So it would have to be the displacement, the acceleration, and the potential energy, because when the displacement is at its largest for me, the acceleration is going to be at its max, and the potential energy is going to be at the max as well. And then V is going to be 0. Kinetic energy is going to be 0. So if I did this, if I did this, like, if I did like a velocity graph, it'd be like this. That was the second question I got wrong. I think. Oh, I forgot to put the mistakes. Okay, so for this question, I put 1, 3, and 5. You know what? I think I might have mixed something up. I think my mistake was just not knowing that graph. I wasn't thinking about that graph. And then for the other one, the kinetic energies, I don't think I was thinking about the equation. Okay, for the next one I got wrong. It was this thing. This problem looks like this. This goes down and it goes up again. It's asking for the distance from 7 seconds to 10 seconds. So this is just the integral on. This is just the displacement formula. I think that was my mistake here. I don't remember if I used it. I probably didn't use it right, because I put 1.5. Either that or it was a mathematical error. So using the displacement formula, we got x of 0, v0, t, 1/2 at squared. Initial displacement is 0, so we can cross that out. So v0t acceleration. Let's see, that's the velocity graph. Acceleration would just be, I'm pretty sure acceleration would just also be 0. Okay, so it's x is equal to v0t. The initial velocity is 3-second time period. One meters a second. At 3 seconds, it's 1 meter. Oh, it's a 3-second timer. Okay, so 7 to 10. 7 to 10. I was thinking 7 to 3. That's why I was freaking bugging. So 7 to 10, 3 seconds. At 3 seconds, it's at 1. So it's 1 meters a second times 3 seconds. So it's 3 meters. That's the answer. Nice. Okay. The next question I got wrong was... What is this? Ah, this one. Okay. Horizontal spring constant K equals 300 meters. So I don't know, horizontal table, so let's draw this out real quick. So there's a spring, horizontal spring. It's block sliding across the thing. I don't remember what I did with this problem. 2 meters a second. Since I picked 2 meters a second squared, I'm just gonna have to assume I did some sort of mathematical error. So let's see, this is just... So we got V this way. And we got friction that way. So this is just F equals ma. So it's just the force of the spring. I guess I could just call it the force of the spring since it's going that way. Minus the force of friction. And it is asking for... the initial acceleration of the block. So I'm finding A. I have to isolate A. So MA. F of S is simply just force of the spring is just kinetic times the distance. So it's Kx minus mu mg. Mu Fn. Yeah, mu Fn straight to mu Fn. Okay. What was it? Ma. These will cross out over m. So you're just left with A is equal to Kx over m minus mu to g. And now it's just a matter of plugging everything in. So we got 0.2, 9.8 minus 300 times 0.1 over 10. And that should amount to 1 meters per second squared. Because this is newtons meter, this is kg. This is meters per second squared. 0.2. Yep. All the units, they should cancel. Yeah, meters per second squared. Boom. Alright. Next problem. Okay, this is just a conceptual one. Let's see. Yeah, this is just a conceptual one. Okay. So it's asking for appropriate evidence. Could the student be able to create from the data to explain the object that undergoes simple harmonic motion? So another simple harmonic motion problem. The kinetic energy and velocity of the circuit portion. Not really. I think they're inversely proportional, so maybe not that one. Storing force and acceleration. Maybe. Storing force and acceleration object to the velocity. Yeah, no, because they're going in opposite directions. One goes 0, one goes max. Storing force is directly proportional to the acceleration. Because the graph doesn't really match. Kinetic energy velocity, no. So it had to be B. The storing force and acceleration of the object are directly proportional. Yes, the displacement. Yes. Because this is just like that last one. with the 1, 3, and 5, I think, where it asks for 3 maximum magnitudes. You can apply the same concept here. Okay, let's see. Oh, that's it. Well, that concludes Unit 7 MCQ 5 out of 10. I think the main problem was the oscillations.